Alright, today's objective, the Pythagorean Theorem. Let's go over some definitions first. Pythagorean Theorem. This describes the relationship of the lengths of the sides of a right triangle. And as you probably have heard it in 7th grade, a squared plus b squared equals c squared. Alright, so hypotenuse. In a right triangle, the side opposite of the right angle. That is going to be your hypotenuse. Okay? That is always going to be the longest side. Legs. Each of the sides forming the right angle. Those are going to be your legs in the formula. Pythag triple. When all the sides of a right triangle are whole numbers. Okay? So let's look at the setup as far as the diagram of a right triangle goes. Here's your hypotenuse, and again, it's the longest side opposite of the right angle, and that is going to be labeled your hypotenuse. In the formula, it's going to represent C in the formula. A and B are your side lengths, and those are always going to be labeled as your legs. Those are the two sides that form that right angle. Okay, let's go over some examples and see all the different types of triangles that we're going to see. So example number 1, here's my longest side. I know that's my hypotenuse because it's opposite of the right angle. So I know that that is my hypotenuse, and that is actually the side we're solving for. So we're always going to begin by putting our formula down. A squared plus b squared equals c squared. Know our two legs. Alright, it's 12 and 18, and that is A and B. And notice that I also have to, this is A squared, so A is playing the role as my base. And so 12, we need to square 12. Alright, and then we're going to square 16. So 144, 16 squared is 256. And then x, being our hypotenuse, we got to square that, so that's x squared. Alright, once we add our sides, we get 400. But notice this step right here. This is very important. Notice I don't have x equals, and that's what we're solving for. We're solving for x, not x squared. So with x squared sitting here, equaling 400, I must get rid of that exponent of a 2, that square, that power of 2. And the only inverse operation that does that is by taking the square root. Those two things cancel each other out. And so x, which is my base, is what's going to be brought down. This is true every single time. So then the square root of 400 is 20. So I must take the square root of both sides. Alright, example number 2. Here we have side lengths of fractions. Okay? It's okay, we're talking about small lengths of things that still form a right triangle. So I have a squared plus b squared equals c squared. So I plug in my legs for a and b. I know I'm solving for the hypotenuse c because I am opposite of the right angle. That is my hypotenuse. Now, once I square, remember I have to square my numerator and then square my denominator. All right, square my numerator, square my denominator. I add them together, that I have x squared equals 1. At this step, again, inverse operation of a square, we need to take the square root. Okay? So there, when I get the square root of 1, that is 1, because 1 times 1 is a perfect square. So that side length equals 1. Example number 3. Here's again another diagram of a right triangle. I can tell that 9 is representing the length of the hypotenuse, and 5 and x are representing my sides. So with my legs. So one of my legs is what I'm solving for, so I'm just going to use A for that one. 5 is representing the other leg, and then 9 is representing my hypotenuse. So when I plug that into my equation, I'm going to follow what my equation tells me to do. My equation tells me to square everything, so I got to square my leg. I got to square the 5, which is 25, and I need to square my hypotenuse length, which is 81. At this stage, we're solving for A. So I need to get rid of the positive 25 by subtracting it to both sides. Then I have a squared equals 56. Again, inverse operation, I need to take the square root of the square. So a equals the square root of 56. And we know how to approximate non-perfect squares. So when you did this, it would be approximately 7.4 as far as the side length goes. Example number 4. Notice I don't have a diagram here. All I have is the side lengths labeled. So my legs are here and my hypotenuse is here. Okay, so I know I'm going to plug in those side lengths for that. And notice that these are square roots, but that's okay. So when I plug in the square root of 5, the square root of 5 squared, remember, this is no different if I had, something like this, right? Those are inverse operations of each other. So this gives me a 5. Okay, those are inverse ops. B squared, and then the square root of 14 squared is just 14. All right, remember that your base is going to come straight down. Now, again, I'm solving for b squared, so I need to subtract 5 from both sides. B squared equals 9, and at that point, I need to take the square root of both sides. So when I take the square root of b squared, my base comes down. B is my base. And then the square root of 9 is positive 3. Alright, the converse of the Pythagorean theorem. What the converse is going to say is that I have these side lengths. Do these side lengths make up a right triangle? In other words, all 3 sides, when I have those side lengths, they're going to construct a right triangle. So 2 of those legs will definitely fit as far as a right angle goes. If a triangle has sides of lengths A, B, and C, and a squared plus b squared equals, this is true. In other words, it must be a true statement, equals c squared. Then the triangle is a right triangle with a hypotenuse c. We can use the converse to determine if the triangle is a right triangle. So if it's not a true statement, if both sides do not equal that, then we know it does not form a right triangle. It could form an acute, a scalene, obtuse, those types of triangles. Determine whether the given lengths can be sides of a right triangle. So let's go ahead and practice the converse of this. So here's 3 side lengths. And remember, I have A, B, and C. So out of those 3, your hypotenuse, your C, is going to be always your longest side. So when I see these 3 side lengths, I know that 3 is going to be represented for my C. That is my hypotenuse length in theory. All right. So let's see if this particular side lengths form a right triangle. So when I plug in my 2 legs and I plug in my hypotenuse, I square both sides and I square my hypotenuse. Now 4 plus 1 is 5, but 5 does not equal 9, so that is not making a true statement. So we know that those 3 side lengths do not make up a right triangle. Example number 2. I have 16 centimeters, 34 centimeters, and 30 centimeters. Again, here is my hypotenuse, and as you can see, I plug that into my C. So when I square my side, 16 squared is 256, 30 squared is 900. I take 34 and I square that, I get 1156. So once I do the math of what the equation tells me, I get 1156 equals 1156, and that is a true statement. Therefore, it is a right triangle. If I actually constructed those side lengths, it would form a right triangle. All right, last example of the converse. Square root of 2, 1, and a 1. I know that the square root of 2 is greater than 1. So I know that this is my hypotenuse. Okay? So that's where I'm going to plug that in. When I square my bases, I get 1 plus 1 equals 2. Again, here's that square root and a square. Those are inverse operations of each other. Then when I add my ones, 2 does equal 2. And that is a true statement. Therefore, that does equal a right triangle. All right. Last one, we're going to do some applications of the Pythagorean theorem. In this one, they're talking about directions. They're talking about a pigeon that leaves its nest in New York City and flies 5 kilometers due east. The pigeon then flies 3 kilometers due north. So he goes east and then he goes north. And notice that that forms that right angle. How far is the pigeon from its nest? So this is where he flew. This is where his home is. So we're trying to find that hypotenuse. This is a very basic type of application using the Pythagorean theorem. All right. So I know that since this is where we were, this is where he was, that is definitely forming the hypotenuse factor since the direction of being east and then north forming that right angle, okay? So here's a squared plus b squared equals c squared. When I square both of my legs, I get 25 plus 9 equals c squared. And remember, at this point, that is where when I have c squared, when I see this, that is not a c. Remember, we're solving for c. So that means I have to take the square root, which is what I'm doing, in order to get a c equals. Very important to know. And then I'm having to approximate the square root of 34. Well, that's about, once we do the math, because we know how to approximate our non-perfect squares, it's 5.8 kilometers.